could you summarize how you see artificial intelligence and if you think AI can be biased?
Absolutely. In the talk, I focused on a type of AI that is typically thought of as machine learning. And machine learning can definitely be biased. And in the talk, I focused on three reasons for or how the bias arises in machine learning. One of them has to do with the objectives of the learning that are often defined by the designers of the learning algorithm. The second is the biases in the data that the learning algorithms are trained upon.
Yeah.
And the third is related to the biases in the representations that the learning algorithms infer or map the input data to. And the learning algorithms, the biases in the learning can come because of any of these three reasons.
Yeah. In the examples that you mentioned during your presentation, you talked about compass as one of the, obviously, the bias within the algorithm itself. So do you see any other consequences and examples on the bias of AI in our day-to-day life?
Yes. So in the talk, I largely focused on algorithms that have been designed to assist or replace human decision makers. But I did not, what I did not cover in the talk are algorithms that are increasingly being used to mediate social interactions between people in our society. That these are algorithms that are deployed on Facebook or Twitter, social media, where they end up influencing what sort of information people see and what sort of people they meet and so on. Now, in those algorithms, biases could come up as well because of the way in which they are aggregating the opinions of the crowds, as well as the way in which they're actually doing the personalization, where they end up showing different users of the system different types of information based on what they predict would be the information that the users would like. So there are lots of biases that could come up because of such personalization of recommendations and personalization of search services as well.
So in the example that you mentioned about the personalization of the information, especially in the social media, so you took the example and showed the unbiased within that. So what would be your recommendation in order that we remove that and have a fairer, I would say, algorithm?
So that's a difficult question, in part because sometimes there is no free lunch, and you often have to trade off between different objectives that one might legitimately have. So for instance, personalization is actually quite useful in social media because it can keep out lots of information that people do not have any interest in. But at the same time, excessive personalization can lead to the formation of filter bubbles and echo chambers where people are essentially hearing information that they largely agree with, and any voices or opinions that they disagree with are screened out or filtered out. And now the question really is how to find a nice balance or a trade-off point between excessive personalization and useful personalization. And this is where interdisciplinary work that is being done by computer scientists who are designing these algorithms in collaboration with journalism and media studies and communication studies scholars can help.
During your presentation, you mentioned a lot about Moneyball and then the application within the baseball. For the participant who couldn't be here tonight, so how would you summarize that ideas and what would you like them to keep in mind?
I think the big idea behind Moneyball example that I was highlighting is that when you have lots of data about, in the context of Moneyball, the past performances of baseball players, one could use statistical analysis techniques to find interesting patterns in the data. The other big idea of Moneyball is that you could actually use the data to test various different types of hypotheses. For instance, the hypothesis that was tested in the Moneyball example was the statistic of on-base percentage actually correlating more with the wins that the team gets compared to what traditionally human scouts thought was a more useful statistic, which was the batting average. So you could have a hypothesis that certain statistics might be more useful to make certain predictions or might be more useful for constructing a more winning team. But these sorts of hypotheses, even if they don't match human intuitions, can be tested in the data, and one could figure out whether they would actually work in practice or not. And that's the big idea behind Moneyball.
Thank you. You mentioned as well about the ethics in AI and having an ethical AI, knowing that the unbiased is one of the concerns for the general public. So regarding the ethical in AI, what would you like people to remember and really to focus on?
I think perhaps the most non-intuitive takeaway would actually be that one needs to focus very carefully on the objectives of learning. So oftentimes people instinctively recognize that if your training data is biased, then the outcomes of your learning would also be biased. But what people, particularly in the machine learning community, even tend to overlook is that some of the unfairness comes from using the default objective, which is to make accurate predictions. And the word accuracy sometimes is misleading because it makes people think that it would make people ask, what other goals could there be other than making accurate predictions? Now, what they often miss is that there is a measure of accuracy that is used in all these systems, and that measure is a very, very utilitarian measure where you think that the best decision is one that minimizes the sum of all individual errors or sum of all errors for individuals in the population. Oftentimes, ethics are about balancing this overall population level error rate with other types of considerations, such as like equalizing group error rates and so on.
So when you mentioned about the issues within the unbiased within algorithm related, for example, for the training dataset being biased itself, so what would be your recommendation to try to fix that problem?
So there are different types of techniques that people are exploring to fix the biases in the training data. One would be to resample the training data in a manner that reflects or that undoes the sampling bias. So for instance, if you knew that people of a certain race were more overrepresented, you could undersample them when you're creating a new training data set. Another set of techniques are a bit more invasive in the sense that certain techniques even involve changing the data labels or even adding non-existent data items to reflect the sort of data that would have been generated in a future fairer society. So there are a lot of these different types of techniques that people have proposed and are exploring. And I think many of them are quite effective. But one would also need to carefully consider if these training data manipulations might have secondary effects. And oftentimes this is one of the big problems with learning. When you try to address one problem, you might end up unknowingly creating many more biases and issues that you might not have thought of.
So you took some examples within the deep learning field as well with the biases there. Similarly, what would be your recommendation to be able to tackle the bias within the deep learning field?
Now, that is a very challenging problem. So what I was highlighting in the talk is a problem that comes from the intermediate representations or latent representations that are often generated by the deep learning methods and potential biases in those representations. However, making sense of these latent representations is a very difficult challenge, and in fact, even people working in deep learning have been struggling with this problem of explaining and getting a handle over these intermediate representations, what types of features they're actually capturing and so on. So some of the progress that is being made in that field might be useful or might prove helpful in the long term with detecting biases in these intermediate representations. But these are there are some really foundational questions in this space that for which we still don't know or don't have good answers.
So for our peers within the AI communities, when handling the biases in data, what will be your recommendation for them and elements that they need to focus on and think about?
I think there are two different questions that one might want to ask. First is, the easier question might be whether the data has been gathered in the correct way and in a correct and unbiased way. The more difficult question would be whether the data represents where we see the society heading towards rather than where the society is now. And this is where there ends up being a tension, because while training on unbiased data might mean that you would want to gather data of the population that exists today, you might also want to make decisions to influence the future evolution of the society, and there you may be tempted to actually use training or gather data or create data of that represents the population or the society that you would want to see the current society evolve into, and there's going to be a tension there between the two things. What is the ultimate objective of learning? Because I see many researchers working in this space often overlooking the fact that they are optimizing for a very specific measure that might not be the thing that is desired in different learning scenarios. And that measure, unfortunately, has this is called accuracy, which naturally makes you wonder what else would you do other than optimize for accuracy. But the precise way in which accuracy is operationalized, that means accuracy is measured, ends up creating a number of different types of biases in the learning process. So that would be the thing that I would hope that the participants would, or the audience would take away.